33. These are the part 3s. I liked this question. It was a good question. Made your brain think. Here we go. Such a nerd, right? That I like questions? Whatever. Here we go. 33 says, Loretta and her family are going on vacation. Their destination is 610 miles from their home. Loretta is going to share some outside... No, sorry. Where am I reading outside from? Hold on a second. Loretta is going to share some driving with her dad. I don't know where I got outside from. Her average speed while driving is 55 miles per hour, and her dad's average speed is 65 miles an hour, just naturally because men drive faster. Yeah, that's true. The plan is for Loretta to drive for the first 4 hours of the trip, and her dad drive for the remainder of the trip. Determine the number of hours it will take for her family to reach their destination. So, here we go. This is the best way to do this question. So Loretta, so I'm going to put this as Loretta's driving, okay? They already tell us that she's driving 55 miles an hour and she's driving for 4 hours, okay? So we know that if we take her 55 miles per hour and we multiply it by 4 hours, we get, let's see, 55 times 4 is 220. So this means that she drove 220 miles. So 220 miles driven. Okay, you can just plug that into your calculator if you want to. 55 times 4. So she drove 220 miles. There's a total of 610 miles in this trip. So let's talk about the dad's driving. Okay? The dad's driving is a little different, because Loretta already drove 220 miles. So that means that if we take the 610 miles and subtract the 220 miles that was driven, there are a total of 390 miles left to drive. Okay? So dad is driving 390 miles. So we just take 390 miles and divide it by the 65 miles per hour. And we get, when we divide this, we get 6 hours. Okay? So the number of hours that it will take for their family to reach their destination is 4 hours, which is given to us, plus the 6 hours driven by her dad. Your answer is 10 hours. It takes 10 hours for them to drive. Okay? So that is the original plan. It will take the trip 10 hours to get there. But the problem is, after Loretta has been driving for 2 hours, she gets tired and asks her dad to take over. Determine to the nearest tenth of an hour how much time the family will save by having Loretta's dad drive for the remainder of the trip. So, we need to do pretty much the same thing as what we just did before, except now we're just changing that 4 to 2. So, let's go back and do this. Loretta's driving. So, things have changed on Loretta. She got tired. Okay? So, she drove, now it's 55 miles per hour times 2 hours. Okay? That will give you 110 miles driven. So, Loretta now drives 110 miles. So, now let's talk about the remainder of the trip. If we take 610 minus 110, there are now 500 miles left. Now, let's calculate the dad's driving. So, now he has a little bit more driving to do. But he drives faster. He's got a heavy foot. So, we're going to take the 500 miles left and divide it by the 65 miles per hour. We get, when you type this into your calculator, we get 7.69 hours. Okay? So, if we take the 7.69 and add it to the 2 hours, right? 7.69, add it to the 2 hours, we get 9.69 hours. Okay? Now, how much time is saved? So, to calculate the saved time, we take the 10 hours minus the 9 hours and 9.69 hours. That will result in 0.3 hours when you round it to the nearest tenth. So, the whole family saves 0.3 hours, or, yeah, just 0.3 hours in the trip. Honestly, that is not too long. I'm trying to think of, because 0.5 is 30 minutes. What is that? Between like 15 and 20. They only save like between 15 and 20 minutes. It's really not that much time, but it doesn't matter. That's the answer. 0.3 hours is what they save with her dad driving. Okay. That's number 33. Number 34, the heights in feet of former New York Knicks baseball players are listed below. Oh, they're going to be tall. Using the heights given, complete the frequency table. Okay. So basically what we're doing is we're taking all these numbers and we're plugging them into the frequency table. So, okay, I'm going to leave this up to you. You need to be very careful. You just need to go through each number and put a tally for each time you see. So, like, for example, 6.4 is in this box between 6.4 and 6.5. Then 6.5 is in the same box. 6.2 is in this box. So I'm just going to leave that up to you. I will tell you that these are the answers. There's 3 tally marks up here. 1, 2, 3, 4, 5 with that cross. 6, 7, 8, 9, 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 1, 2, 3. So this is 3. This is 10. This is 11. This is 0. This is 2. And this is 3. So that's your frequency table for this. Now on the following page, it says, based on the frequency table that you just created, draw and label a frequency histogram in the grid below. So let's just take our time with this. Let's just go through it slowly. So I'm going to count by ones, but really I'm counting by twos. I'm counting by ones on the graph. I'm just skipping the ones just to have more space. So 2, 4, 6, 8, 10, 12. So on this side, this is the frequency, or the amount of times it comes up. So that's the frequency. And on the bottom, this is going to be the intervals of heights. Okay? Now, you don't necessarily need to label your axes, but I highly suggest that you do. So I'm going to make this interval 6.0 to 6.1. I'm going to make this interval, all right, I'm going to change the color, 6.2 to 6.3. This interval, I'm going to make this 6.4 to 6.5. I'm going to make this interval 6.6 to 6.7. Make that interval 6.8 to 6.9. And last but not least, this is 7.0 to 7.1. So now all you got to do is you just got to graph those frequencies. So the blue interval has 3 frequencies. The 6.2 to 6.3 has a total of 10 frequencies. I should really make this a lot cleaner. Yeah, I'm going to use lines. Oh, this is so much better. Look at this. Yeah, I would use a ruler for this just because it just makes it more clean, right? Looks a lot better. Okay. Then we got, let's see, the green portion. The green portion is 11 people. 11 people. Then we got nothing over here. So the purple's good. The orange, there's 2 people. 2 people. Oops. 2 people. And for the last one, we have 3 people. 3 people. Now you just shade it in. With a pencil, pen, whatever you got to do. Shade it in. And that, ladies and gentlemen, is how you create a frequency table. Not too bad of a question. Now for the last part. Determine and state which interval contains the upper quartile and justify your response. So, excuse me, here's the thing. Upper quartile. Upper quartile means the 3rd quartile. So, unfortunately, what they want you to do is they want you to input these frequencies into your calculator and get the frequency. No, sorry, to get the 3rd quartile. So I'm going to do that right now for you. So go on your TI Inspire, go to the application lists and spreadsheets down here. I am going to type in up here, I'm going to type in interval. No, I can't do that. I actually need to type in all of the individual numbers. So, this is going to be a pain in the neck. All right, I need to type in all the numbers. So, what do I just call this? Heights. I'll call it heights. Okay. So here we go. 6.4. I'm just reading this right from the chart. 6.5, 6.2. You could skip this if you want to. 6.9. This is so annoying. 7.1. And it sucks for you people because you actually have a calculator. Like, I'm using a computer. I have a keyboard. So that's certainly a pain for you. 6.4, 7.0, 6.2, 6.3, 6.4, 6.4, 6.3, 6.5, 6.5, 6.1, 6.4, 6.5, 6.3. These are a lot of people. 7, 6, 6.8, 6.4. What's wrong with me? There we go. 6.2 and 6.2, 6.3, 6.2, 6.3. Okay, so I have all that inputted into my calculator. Now what we're going to do is we're just going to do, and we're going to analyze this data. So menu, doc, add a calculator. Menu, statistics, stat calculations. We're working with one variable. We're working with the heights. And your upper quartile is 6.5. So your interval is the 6.5 interval. That's the interval where it lies, peoples. 6.4 to 6.5. The next one's 6.6. That's not the same thing as 6.5. So your answer is the upper quartile lies in the interval 6.4 to 6.5. Or the third interval shown in the histogram. Now it does say justify your response. Okay? So here's the deal. The justification's easy. The justification, you're literally copying your calculator page as shown here. So I'm actually just going to go ahead and copy it right now. It's going to get a little dark here. So bear with me. So on your regions, you are actually going to make this your justification. Keep resolution. This is all right. So this is your justification right here. That's it. And you could show that the third quartile, that the third quartile is 6.5 down there. Okay, that's how you do that question. 35. Solve the following system of inequalities graphically. All right, so they're telling you how to do it because you can't solve this algebraically because they're forcing you to do it graphically, as shown below, and label the solution S. Okay, so let's talk about this for a second. We need to put all these in y equals mx plus b form. Well, obviously these aren't equal signs, but we could treat them as equal signs. So for the first equation that I see, for the first inequality that I see, I'm going to move that 3x over. So we get 4y equals, keep on that equal sign, greater than negative 3x plus 20. Divide by the 4. Okay. We get y is greater than negative 3/4 x plus 5. Now over here, where you're going to move that 18 to the right. So we get x plus 18 is less than 3y. Divide by 3 by everything. And we get 1/3 x plus 6 is less than y. Folks, I'm going to rewrite this a little differently just because the majority of you do not like that way of writing it. You like this way. Y is greater than 1/3 x plus 6. So what I'm doing is I'm switching everything. I'm switching the placement of the y. It's on the right-hand side. Now it's on the left. I changed the less sign to a greater than, and I moved the 1/3 x plus 6 from the left to the right-hand side. Okay? So these are your two inequalities. I'm going to erase this to give me some more room here. And we are going to graph these two equations. Y is greater than 1/3. Okay. All right. So y is greater than 1/3 x plus 6. So, here we go. Here we go. I am going to describe what this is saying, okay? So we know that the slope is 1/3. The y-intercept is 0, 6. It is a dotted line because it's just greater than, that it's not greater than or equal to. And it is shade above. Okay? Over here, this one has a slope of -3/4. The y-intercept is 0, 5. It is a dotted line. And it is shading above. Okay? So now what we're going to do is I am going to create an XY plot. So here we go. I'm going to draw in my X and Y axes because you need to do that in order to get this question right, or else you have nowhere to go. Should this be up one? I love how they don't make these graphs symmetric. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. No, I'm just stupid. That's symmetric. Beautiful. Okay. So, this is the x-axis. This is the y-axis. I'm going to graph my blue line first. So we get y is greater than 1/3 x plus 6. So 1, 2, 3, 4, 5, 6. Up 1 to the right 3. Up 1 to the right 3. Up 1 to the right 3. Now we go down 1 to the left 3, down 1 to the left 3, down 1 to the left 1, 2, 3. That is a dotted line, people. Dotted line. Okay. And it is shading above. Like that. Now for the next one, the y-intercept is 5, down 3 to the right 4, down 3 to the right 4, up 3 to the left 4. Okay, and now we're just going to draw in that red line that's dotted, and we are shading above. And this, ladies and gentlemen, is your solution set right up here. You're done. Actually, you're not done. You could even label these lines as well, because it's always important. Label them as the original lines. So 3x plus 4y is greater than 20, and this is x is less than 3y minus 18. Now you're done. Okay. Honestly, if you get one of those questions, in all seriousness, you should not mess up on those. You should take them, get the points, and run with this question because they're really not that bad. Now, we're done with this part. Now there's another part. It says here, is the point 37 in the solutions that explain your answer? I guarantee that they're asking you, is the point 37 like the point of is this the point of intersection somewhere? Nope, sorry. The point 37 is right here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it's that point right there. Is that considered the solution set of this? No, because it lies on the dotted line. Any point that lies on the dotted line, even if they ask you for this point where it's the intersection point, it's not really intersecting because, again, they're both dotted lines. Anything that's on the dotted line does not work. So we're going to say no or nope. Nope. Because the point does not satisfy the inequality x is less than 3y minus 18. And let me show you your proof. It's because you need to prove yourself because it says explain your answer. So this is actually explaining. You're going to take the point 37, you're going to plug it into the bottom inequality. It does work for the top, obviously, but it doesn't work for the bottom. It needs to be a solution of both systems. So the proof is 3 less than 3 times 7 minus 18? Well, I just took that x value 3, plugged it in, took that y value 7, plugged it in. 3 is less than 21 minus 18. Well, 3 is not less than 3. That fails, so it's false. So that's why it doesn't work. Pretty simple stuff. Not too bad. All right, 36. An Air Force pilot is flying at a cruising altitude of 9,000 feet and is forced to eject from her aircraft. The function h of t equals negative 16t squared plus 128t plus 9,000 makes the height in feet of the pilot above the ground where t is the time in seconds after she's ejected from her aircraft. Determine and state the vertex of h of t. Explain what the second coordinate of the vertex represents in the context of the problem. First of all, let's find the vertex. Unfortunately, folks, you need to do this question algebraically. Let me say that again. Algebraically. If you graph this and you state the vertex, you get it. Well, you get 1 point off. Okay? You need to know how to find the vertex algebraically. And it all boils down to the axis of symmetry. And if you don't know what I'm talking about, let me explain. If you have a quadratic, right? If you have a quadratic that looks something like this, and you're trying to find that vertex algebraically, you can't get that vertex unless you have an x value. And the axis of symmetry always passes through the vertex. Now, there's a formula for the axis of symmetry. It's negative b over 2a. So you could solve for x, take that value, then plug it back into the original function to solve for y. Let's go ahead and do that. So what I'm going to do is I'm going to solve for x first. Solve for x. The axis of symmetry formula is x is equal to negative b over 2a. So we're taking the information given in our equation and we're plugging in the corresponding numbers into our formula. So we have negative. Now the b value is 128. It's that middle number. Negative 128 divided by 2 times negative 16. This gives us negative 128 divided by negative 32. When you reduce this down, this gives you the number 4. So x is equal to 4 in this case. Okay? Now, we need to solve for y. Solve for y. So, all you need to do is you just take the 4, you plug it into h of t, and you get your y value. Remember, input-output stuff. If you input the 4, you get an output of some other number. So we get h of 4 is equal to negative 16 times 4 squared. Just plug it in wherever you see an x. Plus 128 times 4 plus 9,000. H of 4. When you plug this strand of numbers into your calculator, you get the answer 9,256 feet. Now, we got that. So determine, say, the vertex. So the vertex is the point 4, 9,256. Now, let's just say you did not, let me rewrite that a little bit neater. 4, 9,256. Now, let's just say you want to check yourself. Go ahead and graph this into your calculator. Now, I'm telling you right now, it's going to be so big, you're not going to see it. Or it might even look like a line. So, negative 16x squared. Make sure you plug in an x, not a t, because it won't work. Plus 128x plus 9,000. Okay, I told you you can't see it. So, I'm going to go menu, window zoom, zoom fit. Zoom fit, and we'll actually fit it for you. So the vertex or the turning point, so menu, analyze graph, it's actually the highest point on the graph, so it's the maximum point. So click, click. As you can see, it's the x value of 4. So therefore, we know that we got it right. And the vertex is 9,256. Hold on 1 second. Let me just make sure. Menu. I need to fix this a little bit. There we go. So 9,256. Good. So that's our vertex. Now what we're going to do is, and it says explain the second coordinate of the vertex represents in the context of the problem. Well, x is the amount of seconds. Yeah, x is the amount of seconds. Y is the height of the aircraft. Or in this case, she is ejecting. So this is the height of the pilot. So, we're going to say this, our explanation. 4 seconds after ejecting from the aircraft, the pilot achieves a maximum height of 9,256 feet. 9,256 feet. Woohoo. Done. So that's how you do that part. Not too bad of a question, just you need to know how to solve it algebraically, and I highly recommend that you memorize the axis of symmetry formula, or better yet, you could go on my website, find the facts you must know cold for the algebra regions, and that will help you as well, because that will be on there. Now, after the pilot was ejected, what is the maximum number of feet she was above the aircraft's cruising altitude? Justify your answer. So this is what they're basically asking you. They tell you in the problem that the cruising altitude of the aircraft is 9,000 feet. What your job is to do is to take the maximum height minus the cruise altitude. And that will give you the amount of height that she actually flown up. So 9,256 minus the 9,000. The pilot says, what is the maximum number of feet she was? So she was at a maximum feet of 256 feet. That's a high altitude, or that's a high number of feet. So when she was ejected at 9,000 feet, she flew up 256 feet, and then she was falling down to the ground, had a parachute, and landed safely. So that's what happened.